This week's video is on the laws of exponents. 3 raised to the 4th power is an exponential expression where 3, the big number, is the base, and 4, the little number, is the exponent. The entire expression is called a power. Today we're going to discuss some of the rules of exponents. If we have 3 raised to the 4th power, that tells you to multiply the base 3 4 times, which equals 81. Another example would be 5 to the 3rd power, which means there are 3 factors of 5. 5 times 5 times 5, which equals 125. Always expand an exponential expression where the base is a number to equal what its value is. In other words, don't leave it 5 to the 3rd, make it 5 to the 3rd equals 125, or 3 to the 4th equals 81. The second rule we're going to look at today of multiplying powers is if you're multiplying powers with the same base, that rule says that you add the exponents. You'll see the rule in the upper right-hand corner, but look at the green board for an example. 2 to the 6th times 2 to the 3rd equals 2 to the 9th. Now, don't leave that answer as 2 to the 9th. Always expand the base to make 2 to the 9th equals 512. You can see in the second problem, you must apply the power to the power rule. We have 1 over 3 squared raised to the 4th power. That means 1 to the 1st raised to the 4th equals 1 to the 4th because you multiply the exponents. The rule is in the left-hand corner. In the denominator position, you have 3 squared, so you'll raise 3 to the 2nd power raised to the 4th, which equals 3 to the 8th. Again, always remember, expand those number bases to the exponents, and your answer would be 1 over 6,561. The next rule we're going to look at is dividing powers. When you're dividing like bases, you can subtract the exponents. Again, the rule is in the box, but on the green board you'll see a numerical example. 2 to the 6th over 2 to the 2nd equals 2 to the 6th minus 2, which equals 2 to the 4th, which equals 16, because you should always expand. The next rule we're going to look at is the zero exponent rule. A lot of students struggle with this concept. Think about the example on the green board. X to the 3rd over x to the 3rd equals x to the 3rd minus 3 by the rule, which equals x to the 0, which equals 1. Here's where my students always ask the question, but think about this. You know that if you have a fraction, anything over itself, x to the 3rd over x to the 3rd would equal 1, or 3 over 3 would equal 1. That's why x to the 0 equals 1. And that's your zero exponent rule. Last slide for today is negative exponents. This is always troublesome for students. When you have a negative exponent, all that says is take the reciprocal of the base, and then your exponent becomes positive. So if you look at the green board, 5 raised to the negative 3 power equals 1 over 5 to the 3rd, which equals expanded 1 over 125. It's really not difficult. In the second example, if the base is negative in the denominator, that base must move up to the numerator position. So 1 over 3 to the negative 2 would equal 3 squared. 3 is now in the numerator position, the exponent becomes positive, and don't forget to expand the base. So now we have 3 squared equals 9. That's it for this week.